So here we have a convergent plate boundary, and a convergent plate boundary is when two plates come together with compressional forces. Now there are three different types of convergent plate boundaries, and we call those different types different collisions. So you can have an ocean collide with an ocean, or an ocean collide with a continent, or a continent collide with a continent. So in this video, we're going to look at an ocean colliding with an ocean, and then we're going to look at an ocean colliding with a continent. Now, when an ocean collides with a continent, as we can see in this particular diagram here, when an ocean collides with an ocean, both are oceans, meaning oceanic crust, so both are predominantly made of basalt, and so they're equal density. So when they come together on a collision, we really don't know which one's going to win and which one's going to lose. As you can see, the plate on the left is the one that lost in this particular diagram, and it went down in under the other plate, and we call that process subduction. And when that plate subducts down, it pulls the other one slightly down, creating a hole on the ocean floor called a trench. As that plate subducts down, it gets hotter and hotter, and eventually it melts. And as you can see, as it melts, you get little magma chambers created in this area. And those magma chambers burn up through the asthenosphere and burn up through the lithosphere and go through the ocean crust and basically come out as lava onto the ocean floor, forming little tiny volcanoes. Now, those little volcanoes have a special name called island arc volcanoes. In some cases, those volcanoes combine, and in some cases, they get so big that they actually can create islands. Examples of this in the world would be the Aleutian Islands that connect Alaska to Asia, Japan, and the Philippines. Now, because the magma burns through ocean crust, and ocean crust is basalt, which is mafic, the actual lava that comes out is low silica, and so it has a low viscosity and is very runny. So the type of volcano that you get at an ocean-ocean collision would be a shield volcano. So as you can see, the two convection currents are coming towards each other, bringing the two plates towards each other, and the forces that we get in this particular area is compressional. With an ocean-continent collision, it's the same type of thing. So the convection currents are coming towards each other, the two plates are coming towards each other. However, we know which one's going to lose right away because a continent cannot be subducted. So the ocean plate goes down in under the other plate with the continent. And as it does, it drags the plate down and it creates a trench. As the subduction continues and it gets hotter and hotter and hotter, the subducting plate melts, creating magma chambers. And the magma chambers burn their way up through the lithosphere, all the way up through the ocean crust and the continental crust. Remember that continental crust is mostly granite, which is felsic, so it's high silica, high viscosity. So the molten is going to be really, really thick. So what will happen is that it will actually explode out of the surface, out of the volcano, and typically the volcanoes that you get in this area will be composite volcanoes, the really, really dangerous ones. And an example of this would be Mount St. Helens. So you can see the compressional forces bringing the two plates together. The only thing that is different in this particular case is that every time you have a continent, you have a continental shelf. So because of the compression of the two plates coming together, the continental shelf gets squat together and pushed up, way up and over the continent, as you can see in this particular diagram. Now, two examples of this worldwide would be the Rocky Mountains in western United States and Canada, and another one would be the Andes Mountains in western South America. And so in that particular continental shelf, if you had a sedimentary rock like shale, it could get metamorphosed as it gets buried deep into the mountains. So that would be regional metamorphism. So shale could become slate, could become phyllite, could become schist, could become gneiss. I also put on this diagram too, just as an extra, that you can see where the contact metamorphism is, because anything that comes in contact with the magma chambers in this particular area here will get baked. So this is an ocean-continent collision, and the first one that we just did was an ocean-ocean collision.